All right, so in the first section here, we are going to look at the four choices for each of the equations and decide whether or not each one is a solution to that equation. Now remember, a linear equation in two variables does have infinitely many solutions. So this is not a multiple choice. This is more like one of those choose all that apply. Okay, so we have to check all four of them regardless of what happens for the first or second one as we're working. Okay, so what we do is for part A, we're to substitute 2 for the x and 4 for the y, and we're going to see what happens in our equation. So 3 times the 2 plus 2 times the 4, and we're wanting to know, is that equal to 12? Well, 3 times 2 is 6, 2 times 4 is 8, so we're saying that 6 plus 8 is 12. Well, that's not true. So this is not that is not a solution. For part B, we substitute 3 for the x and 2 for the y. And again, does it equal 12? So 9 plus 4 equals 12. That is not true. So B is not a solution either. Part C, we substitute 4 for the x and 0 for the y, and ask, does that equal 12? 3 times 4 is 12, 2 times 0 is 0, so we're saying that 12 plus 0 is 12. And yes, it is. So that one worked. And lastly, part D, if we substitute 0 for x and 6 for y, does that equal 12? 3 times 0, 0. 2 times 6, 12. So we're saying that 0 plus 12 is 12, and that is a true statement. So we have two solutions in number 1, C and D. In number 2, same process. X, y, substituting into our equation, 5x minus y equals 10. So for part A, 5 times x is 2 minus y is 0. Is that equal to 10? Well, 5 times 2 is 10, minus nothing does equal 10. So that one worked. Choice B, if we substitute 3 for x and 0 for y, does that equal 10? 5 times 3 is 15, minus nothing is certainly not 10. So B does not work. Choice C, the point 0, negative 10. So 5 times 0 minus negative 10. So there is a minus in the original equation, 5x minus y equals 10. And then there's another minus sign with this y value. So make sure you get both. There's a minus from the equation and a minus on the 10. And we ask, does that equal 10? 5 times 0 is 0. Minus negative 10, well, two negatives together make a positive, so 0 plus 10 equals 10. And yes, it does. And lastly, choice D, if we substitute 1 for x and 1 for y, does that equal 10? 5 times 1 is 5, minus 1, no, that does not equal 10. So again, we had two answers, two solutions here, A and C. Now the directions change a little with number 3, and now they give us half of a solution point. Again, there are infinitely many solutions. We're given half of a point and asked to find the other half. So in part A, we're given the x, we're asked to find the y. So for part A, we substitute, again, we're using x plus y equals 6. We substitute 2 for x. We don't have the y yet. We'll solve for that, and it's supposed to equal 6. So to solve that equation, subtract 2 on both sides, y is equal to 4. B, I'm given 0 for the x. I don't know the y. So substitute 0 for x. Keep y a variable. Hopefully, you don't even have to show this step, but to make it look like all the rest, if we subtract 0 from both sides, we are left with 6. And part C, Now we are not given the x value, but we're told the y value is 0. So what is the x if y is 0 and we want it to equal 6? Well, again, I'm hoping you don't even show this step, but if you subtracted 0 from both sides, x is 6. Okay, you need all three of those values. These are not multiple choice. These are three-part questions. So number 4 in A, I'm going to substitute 2 for x, so 2 times 2 plus, I don't know the y value, keep it a variable, and that's supposed to equal 8. Okay, 2 times 2 is 4, plus 4y equals 8. Subtract 4 on both sides. 4y is equal to 4. Divide both sides by 4. Y is 1. Question B. This time we substitute 0 for x. Keep y a variable. Set it equal to 8. 2 times 0 is 0. And if we remember from the last problem, we do not really need to show that step where we subtract 0. It's just adding 0 doesn't do anything. So we really have 4y equals 8. Divide both sides by 4. Y is equal to 2. And lastly, question C. This time we're asked to find an x value when y is 0. So 2 times x plus 4 times 0 is equal to 8. Well, 4 times 0 is 0. And we know when we add 0, it doesn't do anything, so that we can ignore that and say that 2x equals 8. Divide both sides by 2 and find x equal to 4. There's one more, yes, one more like this. So number 5, part A, substitute 2 for x, solve for y. So 3 times 2 minus y equals 8. Now there's a little more thought that has to go into this one. 3 times 2 is 6, minus y equals 8, because even though the y looks like it's almost alone there, it does have a coefficient of -1. So it's more than just subtracting 6 on both sides and stopping. Okay? That's -1y that's equal to 2, and we're not trying to find -y, so we need to divide by -1 on both sides. Find that y is -2, not 2. Question B, we substitute 0 for x, and we're to solve for y. So 3 times 0 is 0, minus y equals 8. Having a 0 here does nothing. Let's ignore it and say that -y is equal to 8. Divide both sides by -1 to cancel the negative sign, and y is -8. And lastly, question C. This time we don't have the x, so we'll solve for x if we substitute 0 for y. Subtracting 0 does nothing, so we can ignore that. 3x is equal to 8. Divide both sides by 3. We do not round. 8/3 is a great answer. If you must, you could call that 2 2/3. I prefer 8/3, not 2.6 or 2.7. All right, at number 6, we're going to work through refreshing our memory how we solved, graphed, and understood solution set of inequalities with one variable. So A says we are going to solve this equation. 14 minus 2x is less than 20. We're going to solve for x. So subtract 14 from both sides. I'm left with -2x. You can't lose that negative sign. Still has a less than, and we have 6. Then divide both sides by -2, and hopefully that little bell is going off in your head that says, hey, when I divide or multiply an inequality by a negative, I have to change my inequality symbol. So it goes from less than to greater than. 6 over -2 is -3. So my solution, and it's not just the -3, it's the entire inequality, x is greater than -3. So the way that we usually graph these was we would locate the -3 somewhere in the center of the line. and establish a scale. Well, these are pretty close together, so I'm going to say every third one will be 1. So I'm counting by 1/3. So 1, 2, 3, there's -2. 1, 2, 3, there's -1. 1, 2, 3, there's 0 and 1. This direction, -4, -5, -6. You must establish a scale, though. We decided then, because it was greater than -3, not equal to, that we would have to put an open dot on the -3 to indicate that our solutions were very, very, very close to that number, but not the number itself. And greater than means we wanted to shade to the right. So we had infinitely many solutions, everything larger than -3. So, part C says pick an x value which, according to your drawing, is inside the solution set. Well, inside the solution set means shaded. Okay, so easiest thing to choose would be 0, right? So I'm going to choose x equals 0. What I'm to show then is when I substitute 0 into this original problem, does it work? Do I get something less than 20? Let's try 14 minus 2 times 0 less than 20. Well, 2 times 0 is 0. 14 minus 0 is 14, less than 20, and that is true. So, does the inequality hold true? Yes. Pick an x value which is outside the solution set. So that would have to be a value that is not shaded. I'm going to do my part D over here. So I'm going to choose -6. So if I substitute -6 into my original inequality, that's 14 minus 2 times -6 less than 20. What I'm intending to show here is that I get a false inequality here, that the left side does not end up less than 20. Well, this is -2 times -6 is 12, so positive 12. 14 plus 12 is 26, less than 20. Well, no, that's false. That is not true. 26 is not less than 20. So, no, it did not hold true. Number 7, now, this is the reason that we just reviewed those steps for an inequality in one variable. Now we're going to try it here with 2 variables. It's really just an extension of each of the steps we did there. So we start, part A says to solve for y. So if I take x minus 2y greater than or equal to 4, and I solve for y, that means I'm treating y as my variable and isolating that. Move everything else to the other side. So first, I will get rid of the x by subtracting it. So that's minus x on both sides. That leaves me, can't lose this sign, negative 2y is greater than or equal to negative x plus 4. And then I divide both sides by -2, and there goes that little bell again that's telling me I will have to change my sign. Now, we used to write this as the whole side divided by -2, one fraction bar. It's going to be simpler for you to understand and deal with if we start thinking of that as each of the 2 terms individually divided by -2. Okay, so these cancel. I'm left with y. I have to change my sign from greater than or equal to less than or equal. Now this is negative 1x divided by -2. Well, -1 over -2 is 1/2, becomes positive, and there's an x. 4 divided by -2 is -2. So, part B says, let's pretend that your inequality said equals instead of greater than or equal to. Then it would be an equation for a line. So we're saying we're going to pretend that we have solved this and gotten y equals 1/2 x minus 2. Then, in that case, the slope of that line is 1/2, and the y-intercept is -2. All right? Then we want to graph that. So, numbers look pretty small. I can keep my scale 1s. So I have a y-intercept of -2. That's 1 point. One more point, I can make the line. So the slope of this line is 1/2. That means if I rise 1, and run 2, I have a point on the line. Let's do that again. Rise another 1, run 2. Rise another 1. I can do that until I run out of room. I could also reverse it. Since -1 over -2 is also a slope of 1/2, I could go down 1 and left 2. Down 1 and left 2. That's more than enough points. We actually only needed 2. But I should extend this line now across the graph. And let's see what Part D says. Part D says pick any point that is below that line. So I'm going to choose this point, which is 1, 2, 3, 4, 5, -4. I'm choosing 5, -4. And we're going to substitute that into the inequality and see if it works. By works, we mean, is it true? So my inequality was x minus 2y greater than or equal to 4. If I substitute 5 for x and -4 for y, is that greater than or equal to 4? Well, -2 times -4 is +8. So 5 plus 8, 13 is greater than or equal to 4. Does it work? Yes, that is a true statement. It does fit the inequality. It's true. So 5, -4 worked. Now we want to pick a point that is above the line. Well, for above the line, I'm going to choose this one. That's 1, 2, 3, 4, that's -5, 0. So, again, I'm substituting into my original inequality. I'm putting -5 for x minus 2 times 0 for y greater than or equal to 4. Well, -2 times 0 is 0, greater than or equal to 4. -5 minus nothing is -5, greater than or equal to 4. Well, that's not true. That's a false statement. So the point -5, 0 did not work. So what we're seeing is, just like on a number line when we had one variable, everything, we put that dot in the middle, and then everything either to the left or the right could work. The other side didn't. Well, we're extending that here to two-variable graph, where we have our line we identified, and then everything above or below can work, but the other side will not. So is the solution to our inequality the points below or above? Well, the blue point, the one I chose below, worked. So that's my solution set. And then everything above in red did not. So when they say to shade this, what we'll do with graphing inequalities in two variables is you will always shade literally half of the coordinate plane. Either everything above or everything below your line will be part of the solution, or will be the solution set.